Hello guys, how are you today? So today I'll be explaining the carbon topics, okay? This is only 4 pages and there are no CQDs, so I'm gonna do the carbon topics explanation and I'm gonna open the CQDs and answer them. So first, carbon and its compounds. Carbon, occurrence of carbon. So how can you find carbon or how can you produce carbon? Carbon can be found in large numbers naturally, okay, such as coal, like objects like coal, rocks, fossil fuels, carbonates, proteins, carbohydrates, and fats, okay, and it is found in very small amounts in the air as carbon dioxide. So we know that air is made out of nitrogen, oxygen, and carbon dioxide, and carbon dioxide it's only 0.03% by volume. Now, what is an allotropy or allotropy? I don't know how to say it, of carbon. Carbon has 3 known allotropes, and these allotropes are diamond, graphite, and Buckminster fullerene, or just fullerene. Okay, so diamond is like basically a C bonded to 4 other C's. Graphite is a C bonded to 3 other C's. And Buckminster fullerene, we haven't discussed it yet, so let us read, okay? This is just a recap of what we've done, so let us just read and understand what has happened. So this is the structure of a diamond, and we know that a diamond has strong covalent bonds between carbon atoms. And it's a tetrahedral structure made of linked hexagons, okay? Every single atom is strongly and covalently bonded to 4 other carbon atoms, okay? So there are no free electrons. Since it does not have any free electrons, that means it does not conduct electricity. So we can link it to this property over here. And also because it's strongly and covalently bonded, so the bonds are really strong. You need a lot of energy to break them. That is why it has a high melting point and why it is very hard. Okay, now why do we use diamond? We use diamond for jewelry due to its luster. So like especially girls, and we like to wear jewelry with some diamond because it's very shiny. It's not shiny, sorry, it refracts the light, so that's why it's like really pretty. Cutting tools due to its hardness, there's diamond cutters, there's diamond saws, etc. Rock borers, also to cut rock made out of diamond, and abrasive material. So just like in general, diamond is used for its luster, for its beauty in some sense, and for its hardness. Now we move on to graphite. As you can see in graphite, it has a totally different structure. We have strong covalent bonds between the carbon atoms, so we have strong bonds that they look like hexagons, but between these bonds we have a layer. This layer has the electron cloud. Okay, so what you need to know is that these forces over here are strong covalent bonds that are between the carbon atoms. Because they are strong covalent bonds, okay, then they have a high melting point, again because they are strong, and at the same time they are a bit hard, they don't break easily, okay? Now, first of all, the structure of a graphite is that it's a hexagon where every carbon atom is strongly and covalently bonded to 3 other carbon atoms. So there's one free electron left. These free electrons, which is here, they form a cloud of electrons over here, and in this cloud there are weak van der Waals forces of attraction, and this causes the graphite to be soft and slippery, okay? And because the electrons are free, there are free delocalized electrons, it will carry a current. Okay, that's pretty much it for graphite. Now some uses of graphite are like furnace lining, electrodes, lubricants, pencils, and etc. Now compare between the structure of diamond and graphite. Draw a diagram for each. I'm not gonna draw, I'm just gonna like go up. So the structure of a diamond is tetrahedral, shaped like a hexagon. Every carbon is strongly bonded to 4 other carbon atoms and there are no free electrons. Whereas in graphite, they are a bunch of hexagons where every carbon is strongly and covalently bonded to 3 other carbon atoms, leaving a free electron, and all of these 3 electrons, the free electrons form a cloud of electrons or a delocalized electrons, and this causes its electrical conductivity. So if you were to draw it, it looks like this. For the graphite and for the diamond, it looks like this. Okay, now graphite is soft and conducts electricity, while diamond is hard and does not conduct electricity. Explain. So because there is an electron cloud formed by the free electron in graphite, okay, there are weak van der Waals forces. These van der Waals forces cause the graphite to become soft, and the free electrons in the electron cloud that causes the van der Waals forces, okay, this causes the electrical conductivity. All right, whereas diamond does not have these gaps or these clouds of electrons. Instead, it's hard, and because there are no free electrons, it does not conduct electricity. Now we reach to something new, which is Buckminster Fullerene. Okay, so Buckminster Fullerene, its structure, let us read about its structure. It is a molecular with each molecule consisting of 60 atoms. Now this is a big molecule, okay? Each carbon atom forms 3 bonds. That means each atom bonds to 3 other carbons, but pay attention. Here, if you notice, it forms the shape of what? Of a pentagon, whereas above it forms the shape of hexagon. Here and here they also form the shape of hexagon. So how is fullerene different from graphite and diamond? It is molecular, okay, whereas graphite and diamond are network solids, all right? And that's pretty much it for Buckminster Fullerene. Then we move on to silicon. Okay, so now we are dealing with silicon. Silicon belongs to the same group as carbon, although it's a network solid. So silicon dioxide, or silicon IV oxide, or SAN, they are all what? Network solids. So what we can make out of this is that network solids definitely forms hexagons, as you can see from the shape. So network solids forms hexagons, whereas molecular solids, as we've seen here, formed pentagons. So let us see what is the structure of silica or silicon dioxide or silicon IV oxide or SAN. Okay, so the structure is that it's tetrahedral, just like diamond, of linked hexagons, again like diamond, where every silicon atom is strongly and covalently bonded to 4 oxygen atoms. And every oxygen atom is strongly and covalently bonded to 2 silicon atoms, leaving no free electrons. Okay, so now some properties of silica is that it does not conduct electricity. Why? Because all of its electrons are being bonded to something, so there is no free electrons, so it cannot conduct electricity. It has a high melting point, but not higher than diamond. Why? Because it's strongly and covalently bonded. And it's very hard because of the same reason. Now, it's used for microchips in computers. Now, here we have the reactions of carbon. Okay, so carbon has 2 main reactions, okay, which is incomplete combustion and complete combustion. So let us first start with the complete combustion. Complete combustion states that carbon as a solid plus oxygen as a gas, because oxygen usually is put as a gas, is gonna give us CO2 as a gas. This is the complete combustion. Okay, but this is if you are looking to form carbon dioxide. But if you are not looking to form carbon dioxide, instead you're looking to form carbon monoxide, you are gonna do incomplete combustion, which is 2C solid plus O2 gas will help us form 2CO gas. Okay, now the process of complete combustion produces more energy than incomplete, so definitely remember complete combustion has more energy than incomplete. Okay, and now we move on to statement number 2. Reducing properties. In some of its reactions, carbon acts as a reducing agent. Okay, so reducing properties. In some of its reactions, carbon acts as a reducing agent. So what does a reducing agent mean? A reducing agent means it undergoes oxidization. And again, we said, what does oxidization mean? Oxidization or sorry, it's not oxidization, it's oxidation. Please guys, don't get it wrong, oxidation. So it will undergo oxidation. That means it either gains oxygen or loses electrons, or its oxidation number increases. Okay, so here definitely its oxidation number is going to increase from 0 to +4. So here it is a reducing agent. Same goes from over here. Here it will increase from 0 to +4. So reducing agent means it undergoes oxidization, so it gains O2 or loses electrons, or its oxidation number increases. Okay, so now we're discussing carbon dioxide. We need to discuss sources of carbon dioxide. Some sources of carbon dioxide include that it's a product of respiration. So what is respiration? It uses sugar plus oxygen to form carbon dioxide and water. Then it's the decomposition of animals and plants. When animals or plants die, they release oxygen. Complete combustion of fossil fuels. If fossil fuels combust completely, they will form carbon dioxide and water. And when a carbonate, an acid and a carbonate react together, they will form carbon dioxide for sure. Okay, and then when metal carbonates decompose thermally, there will be formed of carbon dioxide. So when a metal carbonate is heated, a colorless gas, which is carbon dioxide, is produced. So for example, CaCO3, a metal plus carbonate. This is a white solid. When it decomposes completely or is heated, okay, it will form carbon dioxide. Same thing with the green solids. It will form, with the CuCO3, it will form CuO solid and CO2 carbon dioxide. Now, carbon dioxide is a black solid, so please remember this. Test for carbon dioxide. Test. Pass gas through clear lime water for a short time. Okay, so very simply, if you want to test for carbon dioxide, you have to put in it lime water, or you have to pass it over lime water for a short time. The result is that lime water turns milky or cloudy, and the equation is CaOH2, this is lime water, plus the carbon dioxide will form the calcium carbonate, which is a white solid plus water. Okay, if the gas is passed through lime water for a long time, the turbidity disappears as soluble calcium hydrogen carbonate forms. So that's why we keep it for a short time and not a long time, because if you kept it for a long time, it would dissolve or become soluble in the water, because HCO32 is aqueous and soluble in water. And an important note is that CaHCO32 is always aqueous and never solid. So that's it for the paper part, or like the explanations part. We'll move on to the solutions, or no, not the solutions, the answers or questions part. Okay, so here are the questions. We start off with section 4.1, occurrence of carbon. Graphite and diamond are allotropes. What does that mean? What are allotropes, first of all? Allotropes, they are from the same element, okay? But they have different structures. So even though they're from the same element and the same physical state, meaning they're both made of carbon and they're both solids, they have different structures. As in diamond bonds to 4 carbons, whereas graphite only bonds to 3. Compare the structure of diamond and graphite, draw a diagram for each. So definitely I'm not gonna draw, I'm just gonna compare. We know that diamond is a tetrahedral structure and every carbon atom is covalently or very strongly bonded to 4 other carbons, and there are no free electrons. Whereas for the graphite, it's a bunch of hexagons where every carbon atom is strongly and covalently bonded to 3 other carbon atoms. So there is 1 electron that's left, and this forms a cloud of electrons in between the layers that has weak van der Waals forces, okay? Now they said, list major uses for each of graphite and diamond. Very simply, graphite can be used for furnace linings, electrodes, lubricants, and pencils, and diamond can be used for jewelry, glass cutters, rock borers, and abrasive material. Now, graphite is soft and conducts electricity, while diamond is hard and does not conduct electricity. Explain. Very simply, it's because of the electron cloud layer in between the graphite, okay? And in the electron cloud layer, there are van der Waals forces that is happening between the free electrons that are present there. So the free electrons that are present in the electron cloud will have van der Waals forces of attraction, okay? And this causes graphite to be soft. And the free electrons explains the electrical conductivity. Now this happens because graphite is bonded 1 carbon to 3, whereas diamond is bonded 1 carbon to 4. So in graphite there is 1 free electron. Okay? Moving on to 4.2, they said the reactions of carbon. They need us to write the chemical equation of combustion reaction of carbon and identify if it's a redox reaction. So the combustion reaction of carbon is C solid, okay, plus O2 gas, okay, will give us CO2 gas. Okay, and since the carbon has gained the oxygen, we can say that it is a redox reaction, okay, because also the oxygen lost oxygen. So saying it in that sense doesn't make sense, okay. So what we're gonna do is we're gonna check the oxidation number. This is 0, this is also 0. But here it becomes +4 and -4. So because one, their oxidation number increased, the other decreased, there was oxidation and reduction, so a redox reaction occurred. Now they told us, write the chemical equation to show how carbon can reduce lead oxide PbO into lead. So very simply, it's just carbon solid plus 2 PbO solid. Actually, if you don't know what it is in the beginning, just write what you know. Carbon is a solid, first of all, plus PbO, which is a solid, okay, is gonna give us, they said they will change it into lead, and we know lead is Pb, so Pb solid plus CO2. Now, CO2, this you have to remember it, so carbon solid plus PbO solid plus Pb2 gives us CO2. Now this isn't balanced, so to make it balanced, we're gonna put 2 here and 2 here. So it's gonna be carbon solid plus 2PbO solid, 2PbO solid, sorry, will give us 2Pb solid, okay, plus CO2 gas. Okay? Moving on to question number 6 about carbon dioxide. They said an article in a magazine assumes that carbon dioxide is produced as follows, which is true. We know it's produced during respiration. Also, it is produced when calcium carbonate reacts with dilute hydrochloric acid, so a carbonate reacts with an acid, and also when methane burns in the air. So the 3 of them are correct because the 3 of them produce carbon dioxide. Now, how do you test for CO2? State what happens or what will be observed if excess CO2 is used. So to test for CO2, we are going to use lime water. Okay, we're going to pass the CO2 through clear lime water for a short time. So when the clear lime water, when the CO2 is passed on the clear lime water for a short time, the reaction is going to be like this. It's going to be CaOH2 plus CO2 gas is going to give us CaCO3 solid. So it will form CaCO3 solid plus H2O liquid, okay? Now, the CaCO3 solid is formed by the CO2 passing over the CaOH2, which is the lime water. This is lime water, okay? Okay, now what happens when excess CO2 is used? When excess CO2 is used, what's going to happen is that the CaCO3 solid is now going to react with the H2O liquid and the CO2 gas to form something that is called CaHCO3 aqueous, and this is always aqueous, it can never become a solid. Now they said, which of the following does not produce carbon dioxide? Definitely petrol has carbon dioxide, Coke also has, adding nitric acid to sodium carbonate also has, so an acid to a carbonate, another acid to another carbonate, but E is wrong because it's an acid to carbon, which doesn't make sense. To make carbon dioxide, you have to put an acid to a carbonate. Moving on to question number 9. List 3 uses of carbon dioxide. You use carbon dioxide to manufacture soft drinks or mineral water, for fire extinguishers, so you can see carbon dioxide in the liquid form, in the gaseous form in the soft drinks and mineral water, and you can find it as a solid, as, I don't know if you know dry ice. Yeah. Okay, so again, you can find carbon dioxide gaseous state in manufacture of soft drinks and mineral water. Okay, and then fire extinguishers as a liquid. It's not really a liquid, it's more of like a foam. Okay, and then creating dramatic effects in television studios and events with the they use dry ice. If you know, it will create like a small steam, if you want, or mist, or I don't know what you call it. So what are photosynthesis and respiration, and what are produced in each? You should know that photosynthesis is the process by which the plant makes its own food. Okay, so the plant uses carbon dioxide. The equation for photosynthesis is this. Photosynthesis, it is very simply carbon dioxide, so 6 CO2 plus 6 H2O plus sunlight energy in the presence of chlorophyll is gonna give us sugar, which is C6 actually. H12O6 solid plus 6O2 gas. Okay, so this is the equation for photosynthesis. Now, for respiration, we know respiration is the process of burning food to produce carbon dioxide, water, and energy. And the equation of respiration is gonna be the complete opposite of photosynthesis. So it's C6H12O6 plus 6H2O plus sunlight energy. Oh, sorry, this is... Okay, I mixed up, my bad. It's not the 6H2O. I forgot, oh my goodness. It's C6H12O6. Please, guys, don't do the same mistake as me. Plus 6O2 gas, okay, is gonna give us 6CO2 gas plus 6H2O plus energy. Okay, so now we move on to question number 11. So silicon oxide and carbon dioxide have similar formulae but different types of structure. Write the formula. Silicon dioxide is like this, SiO2, and carbon dioxide is CO2. Now, how are the structures of the above compounds different? Because SiO2 is giant or macromolecule, so it's a network solid, while CO2 is a simple molecule. So we can say that SiO2 is a macro giant molecule, where this is a simple molecule. And you can also say that this is a network solid. Okay, now what do diamond and silicon oxide have in common? Very simply, they both have a tetrahedral structure, and they are both network solids. So they have strong covalent bonds that hold their atoms together. They both have no free electrons, and they are both non-conductors. Okay, so now we move on to question number 12. Okay, what will be observed when HCl is added to Na2O, Na2CO3 aqueous? Write an equation for the reaction. So very simply, the reaction is gonna be Na2CO3 solid plus 2HCl aqueous, okay, is gonna give us 2NaCl aqueous, okay, plus H2O liquid plus CO2 gaseous. Okay, so please do memorize this. Then they said, what will be observed when a small amount of carbon dioxide gas is added into a clear solution of lime water? Very simply, you will see a white precipitate, and the equation is CO2 gas plus CaOH2 aqueous is going to give us CaCO3 solid plus H2O liquid. Okay? I just want to check how much more we have. I don't think I will do any top questions. Okay. So I'm just gonna check until where we have. So to be honest, I don't know where I am supposed to stop. So I'm gonna do them all because to be honest, I don't want to miss like anything and then it will come in the exam. Okay? So we move on to question number 13. Write an equation to show how carbon monoxide is produced from incomplete combustion of carbon. Very simply, just write this equation, which is 2C solid plus O2 gas will give us 2CO gas. Okay, now this 2 physical and 1 chemical property of carbon monoxide gas. It's very simply a reducing gas which is colorless and odorless. Now write an equation to show how much carbon monoxide reduces zinc oxide. So zinc oxide solid plus carbon monoxide gas. Okay, it will form zinc solid plus CO2 gas. That's pretty much it. So we move on to this over here. Okay, so question number 14 in the diagram below shows a furnace used in heating limestone. Identify the solid product and the waste gas produced. So when you heat limestone, what is the waste gas produced? Is carbon dioxide and the solid product is lime. That's it. Very simple. We move on to question number 15. How do you test for carbonates? To test for carbonates, you are going to add hydrochloric acid and it should be dilute. So to test for carbonates, okay, so you add a few millimeters of dilute hydrochloric acid to the sample. As a result, you see effervescence, a colorless gas will appear. This is carbon dioxide. And then to test for the carbon dioxide, you're going to add lime water. You're going to let the carbon dioxide to pass over the lime water. And if it turns milky, then yes, it is carbon dioxide. Now, question number 15. How do you test for carbonates? Very simply, to test for carbonates, okay, you need to add a few millimeters of dilute hydrochloric acid. Okay, we already discussed this. Why did I repeat it? My bad. Okay. So we move on to question number 16. Question number 16 says that the diagram below shows the pH values of soil in X and Y that are 2 parts of a garden of a house. The owner of the house wanted to use lime to neutralize the soil. Okay, to which part should he use it? He should use it in part Y because the lime is acidic. Actually, it's not acidic, my bad, it's basic. Oh, I understood this because the pH is acidic, so the soil is acidic. So because lime is basic, it's gonna like neutralize the pH value, you know? So that was my bad, my apologies. It's actually basic. Question number 17. Okay, I believe I'm gonna stop at question number 23. So question number 17. List major uses of CaCO3. You can use it as a powder to neutralize acidity, production of cement, production of glass, and extraction of iron to neutralize acid gases. Okay, now a student drew a diagram, okay, representing the uses of limestone. He drew the diagram below. Which of the above is the correct use of limestone? So very simply, correct uses of limestone are actually 1, 2, and 3. Okay, we move on to question number 18. Actually, I don't believe we have question number 18. We do have question number 19 though. So calcium carbonate reacts with dilute hydrochloric acid. So this equation is going to be CaCO3 plus HCl plus CaCl2 plus CO2 plus H2O. Okay. The rate of the reaction can be followed using the apparatus below. Explain why the mass of the reaction mixture decreases within time. This is because carbon dioxide is evolved and it will exit through the gas and like the weight is going to decrease. Okay, so when heated, calcium carbonate breaks down to form calcium oxide and calcium dioxide. Which two words describe this reaction? Very simply, it's decomposition and endothermic. Okay, so definitely it's gonna be decomposition because you are decomposing the calcium carbonate, it will become carbon dioxide. And because it is decomposition, okay, it is an endothermic reaction. So we move on to part D. Calcium oxide is used in flue gas desulfurization. Explain how flue gas desulfurization works. Again, I don't think we have D. Okay, but we can answer E. Calcium oxide is used to neutralize acidic solids, making mortar and steel making. 20, we don't have it either. Alright, 21, I don't think we're supposed to take it. So please, until we're aided, this is all I think we have to do. So thank you guys for watching. I hope you enjoyed and have a wonderful day.